Okay, so if we're talking about, basically we're talking about how functions act and what they do. Okay. End behavior talks about going out way out to infinity and what happens there. And increasing and decreasing is what is happening within the function you can actually see on the graph. Right, so we're talking about the picture and what goes on way out far. Let me draw a basic. Go ahead and put y equals x squared on your paper. That's terrible. This is a sketch of y equals x squared. What? Well, yeah. So increasing and decreasing, first of all. Obviously, these are going different directions, right? Which one of these tails is increasing and which one is decreasing? Or are they both increasing? Both increasing. Okay, so yeah, it's a common misconception that the arrows point away. Okay. The thing with increasing and decreasing is we're always moving to the right. Okay, so as this one goes to the right, what's actually happening? Decreasing. Okay, so we go from left to right. This is actually decreasing, and this one is increasing. Okay. There's a transition point here. This is called a critical point. Thursday, we will go into detail on critical points. Okay. Just for now, note that it's a transition from increasing to decreasing, and vice versa. So, decreasing, we're going down to the right. Simple as we can put it, down to the right. And increasing is up to the right. Conceptually, that's what we're looking at on a graph. So here we are decreasing for x less than 0. We are increasing for x greater than 0. You want a more formal definition? This is how your book puts it. For increasing. So basically what we're saying is any A and B are x values. So if I have an A that's less than any value of B, put it on
A is smaller than B, that means f of A is smaller than f at B. Your book writes it this way. Personally, I would probably put this as a greater than on both of those, just because increasing, it shows something bigger. That just makes more sense in my mind. So the Mr. Arthur interpretation is probably right like this. Just so greater than increasing, they kind of match up. Okay. But that's how your book writes it, so like that small. Or nope. We'll just leave it as is. And there's a similar one for decreasing. The signs are opposite. So just wrote the signs are opposite, it's decreasing. So if A is less than B, f of B is less than f of A. Any questions about increasing or decreasing? Make sense? Up to the right, down to the right. Okay. What about infinity here? This is where we're kind of starting to look at the infinite. You guys know what infinity is? It's way out there, right? Is there a specific number? No, it's not. It's a concept. We're a long ways out. And we keep going. This is kind of our notation. So this would be as x approaches infinity, or goes to infinity. Some people prefer that language. At this point, it's not really particular. This is more of a calculus notation, so if you're hereditary, you might start using that word. So x is going to infinity. That's this direction, right? X, the positive infinity for x is this direction. What is happening to the y value? Is it going up or down? Up. And that is positive or negative infinity. Positive. So that's all we're doing is mapping where that thing is going on for x. So as that's okay. Now as x approaches negative infinity, so we consider the x positive and the x negative every time you can start your statements with these. As x goes to negative infinity, where is the y going? Positive infinity. So if you need to draw the arrows, do it. It tells you right what you need to write. Okay? Questions there. These are just big concepts. Let me draw another one up here. See what you think. That's okay. You don't have calculators. Make sure you can grab the calculator if you don't have one. Go ahead and put that in your calculator. I'll put it in mine. Right, take it way too fast. Yeah. And your y equals screen. I'm going to show you how to find your critical points on a calculator, and then you can identify where it's increasing and decreasing. The maximum and local maximum and minimum, which we're going to get into that. Good? A lot of your windows might be goofy. Yeah, see, my window's goofy. I can't see much. The best way to fix it real quick is go to Zoom 6. Just hit 6, it'll do it. Bam. It fixes it. Go to that. Can we see the top critical point up here? We gotta fix that window. So I'm gonna increase the Y value, the Y max to 20. Let's see if that helps. Oh, still not there. You can use Zoom fit as well, yes. If you're in Zoom, go down to 0. Zoom fit, it'll show the whole thing on the display. So we have our graph. What are our critical points? We're going to calculate them. So go to second and hit the trace key. We want the minimum and maximum. Okay. Which one do you want to do? The left? Okay, let's do the minimum first. So we're going to calculate a minimum. That would be this one, right? We're looking for that point. So a left bound means we need to be on the left side of that point. So I'm to the left of it with my cursor, right? Correct. Now we hit enter. And now I need to go to the right side of it. And hit enter. And then I need to put my cursor where I think it actually occurs. As close as I can get it. So I want to put it somewhere on that page. Then I hit enter, and it gives me my minimum at 1, -4. Got it? Or do you need help? So that's just a sketch of the graph. Here is our minimum. Okay. You with me? If you'll calculate your maximum, we want this point now. Using the same method. Second, trace max. Go left down, right down, and then yes. I get -2 and 23. The decimals occur on those in the calculator because we are less than perfect when we select our guess and our left and right balance. So. Got it? Okay, let's finish this problem, and then I'll help those of you that need it, because we're almost out of time here. But we have tomorrow too. So, where is this function increasing? Maybe this is the transition point. Is this increasing? Up to the right? Up to the right? Okay, so x less than -2, and is it increasing from here to here? Here on out. Yes or no? And x is greater than. So increasing here and here. It is decreasing in here, correct? Down to the right. That would be -2. Between -2 and 1. Now, as x goes to infinity, what does the y do? It goes to infinity, right? As x goes to -infinity, let me write the workup. It's not due until Thursday, so it's posted online too. If you want to go. I posted it yesterday in the afternoon. So it should be, it's there. I'm pretty sure it's there.
Still here.
Oh, stop it, Chad.
Stop it for you.
Jerk.